Alright, so for problem number 2 for exercise 2 here, it's asking us to write a program that's going to draw this picture, and it gives us a couple of clarifications on this to help us understand kind of how exactly this picture was drawn. They say that the innermost square, the square right here, is 20 units per side, so we know that we're going to have our draw square program, the first iteration of it here, do a square with a size of 20. Now, we can absolutely for this reuse the same sort of draw square function that we've been using so far, that we've defined back in last chapter and finally put into a function form during this chapter, during chapter 5. And that looks like this right here. It's the same one that you use theoretically for exercise 1 here. So it's just that simple for loop that we had, that where 4 times our turtle goes forward the size that we give it and takes a 90-degree left turn. And we know that if I load up the answer here for this and run it, we know that at the end of that it's going to leave the turtle in this corner. For this one, we added on the extra walking forward here to move them out of the way. But at the end of that draw square program, it always ends up with the turtle, if we do it the way that we have it listed here, facing outwards from the square from the bottom left corner. So if we're going to use that exact same program, what we're going to have to do is, if we think about it in steps, have our turtle draw that square of 20 units, and they'll end up facing this way. And then what does he need to do? Well, to get to our next square that we need to draw, he has to go down over here and then draw that square that we assume is 20 units bigger per the specifications here. So the square that is 20 units bigger, he then draws that. It ends up back up again in this bottom left corner facing to the right. And then he has to move again down into the left, draw another bigger square, down into the left, draw another bigger square, down to the left, draw another bigger square. So we're going to be drawing 1, 2, 3, 4, 5 all together. And because of the way that we're using our draw square function, it means that the turtle is going to end probably at this bottom left facing right. So it gives us that, the turtle ending up here gives us some idea of how they have constructed their program that's going to draw this set of 5 successively larger squares. And that we can tell, because it ends up down at the bottom facing the right like this, that the last step of their program has to be moving the turtle down here and facing him to the right. And we can tell that that move had to have been achieved with the pin up. So we know that the last thing that we're going to do in our for loop when we ultimately draw this is going to be moving our turtle out of the way to the bottom left, making sure he's facing right, and probably put his pin back down. Though we could have him put his pin down at the start of the for loop, as long as we choose one that works for us. Okay, so all of that said, I think we have a good place to start. So let's just start just by getting our initial stuff that we're going to be doing for most of these out of the way. And the first one is importing any modules that we need to use. In this case, obviously, we are importing the turtle module because it's the only way we could possibly do this. Then we want to make sure that we leave ourselves space to write our main function. Again, try from now on, rather than just having loose code sitting around in the blank spaces, try to use main functions and then call main at the bottom of your program file. It'll be good practice for later on when we start writing more complicated programs that we are actually running from the command line. Okay, so we're going to leave space in here for the main body of our program. And then at the bottom, we are going to call main, just to make sure that it runs. And make sure that your indentation on this is correct. Make sure that you have this call to main at the bottom of your program file. Make sure that you have it left aligned all the way up against the highest level. Remember that Python is very picky about that. So if you leave this main call actually inside of your definition of the main function here, it's never going to run, and your program won't actually do anything at all. So make sure it's down at the bottom. Okay. Now we know, just because of the way that we are doing this, right? We just use draw square definition up here to draw squares. And we already have used that multiple times during the chapter. So we're just going to, because we know that this problem involves using a turtle to draw a square multiple times, that we're probably going to want to have that as its own function. It makes sense to do that, to break it out like that in a way that makes the program more compartmentalized. So we're just going to have our definition here. So we're going to define a function called draw square. You can name it whatever you like as long as it works for you. Draw square is a good name though, because it does describe what this function is going to do. Remember in Python, generally if we have two words in a name like this, whether it's a variable or a function name, that we tend to use what we call snake case, which is all lowercase words and separated words separated by an underscore. So draw square, and the parameters that's going to take are t and sz for turtle and size. So size is going to be some integer that's going to find the size of each of the sides of our square, and t is going to be a turtle object. So we'll even write ourselves a little doc string here for this program. Draws a square of side length let's not do that, sz, using turtle t. There we go. Alright, and we will give us some space there to work in. Alright, so remember that our draw square function is very simple. We just have a for loop that goes for range of 4. So for I in range 4, we want to have our turtle move forward by size. So we're using these parameters here, these arguments that we've passed in via the function declaration here. So these local variables of t and sc, we can use those in our function here, and then when we call them later in main, we can substitute those parameters for whatever arguments we want to pass in, the name of our turtle and the numbers. So we can just use those here like this. So we're going to have our turtle go forward by size, and we're going to have him turn left 90 degrees. That's all we need to do. That'll have our draw square function working just fine. So then we drop down into main. What do we need to make our turtle do? Well, the first thing, in main we need to create a turtle object. Well, I cannot type today. Then we want to initialize our background, our screen, and then we want to have the turtle draws square of size 20, and turtle draws 4 more squares, each 20 units larger than before. Okay, so that's kind of what we want to happen. So let's go through those and knock all those out. So first thing we want to do is create a turtle. I'm going to name my turtle, in this case, Taylor. So turtle. We'll talk more about what these actually is doing here in a later chapter. But for now, just remember that when we want to create a turtle, we need to give a variable and assign it using the assignment operator, the equal sign, to turtle.turtle lowercase turtle dot capital turtle, and then our parentheses. Well, we can't just leave the turtle with its base things here, especially if we want to copy this picture up here exactly. That color we know based on both this and previous assignments is hot pink. So we'll have Taylor be hot pink. You guys can obviously use whatever you like. And I know for a fact that the pin size for those these images that they use here in the book as guides, the pin size they use are 3. And again, none of that is super important, but in this case, we'll try to match it exactly. You can use whatever colors or whatever pin size you want, as long as the pin size isn't so big that it completely messes up the picture. Alright, then we need to initialize our background. And again, remember that we do that by setting a variable to turtle.screen. Again, capital S for screen. We use by convention here WN for window. You can use whatever variable you want, but anytime you see it in the book, we'll use WN just by convention. And we need to give our screen a background color, which is WN.background color, BG color. In this case, we'll use light green, just like they do. That's all we need to do for that. Alright, so I have these 2 lines here that we need to do. We need to have them draw that square to size 20. And I also missed a step. We need to have our turtle move to new starting point. And then have them draw 4 more squares, each 20 units larger than before. Okay, so let's get started by having our turtle draw the first square. That's an easy way to start. So we're going to call draw square using Taylor. And we're going to have Taylor draw a square of size 20. So actually I will move my comment above this here. Make sure that at the end of your main program here, we have wait for click to exit program, and we just have that exit on click method run from WN here. This is just, again, the standard stuff that we'll put for all of our turtle programs. So we'll just leave that down at the bottom of our main function. That way it will not exit the program and erase your screen, because otherwise it will get rid of it immediately. I see I made a typo here. There we go. Okay, so if I run this now, all we're going to get is our turtle. Whoops, I have bad input on line 6, which means I have bad input here. Why is that not working? We'll just comment that out for now. Nope, still wrong. Okay, what do we do wrong here? Oh, I forgot in. There we go. That was my bad. Again, common mistakes. Just make sure you don't make them. Alright, so that draws that first square, and again it ends us in the bottom left. So we know from here we have to go down to the next starting point of our next square, right? So to do that, we need to move our turtle. If we're thinking about this logically, the next square is going to be 20 larger than our first square. So if it's 20 larger, it means it's 10 larger on this side and 10 larger on this side, meaning that this space in between this line here and this line here is 10 units. And same for this to here and here. So if we want to move it from here to here, our first instinct might be to move him 20 units out of the way, and then 20 units down to get to this. That's not right, because it would move us down way over here. We only are moving him away on half of the square, so we need to go half the distance. So he's actually needs to move 10 over and 10 down. So we can do that this way. Let's just move him 10 backwards. So Taylor forward -10. Remember that if you want to use negatives and in your forward method calls, it'll move them backwards. You can do backwards 10, if you prefer. It doesn't really matter. I just personally have always liked using the negative numbers. I think it makes the code more obvious to me rather than having different method calls, thinking instead of the picture as positive and negative rather than forwards and backwards. It just makes the math, I think, easier to handle. So whatever you prefer is fine, but I'm going to have my turtle move backwards 10 by moving forward negative 10, if that makes any sense. So that's going to, if you look at the picture up here, that's going to put our turtle from here back to here. And then we need to turn him right 90 degrees so he's facing downwards, and then have to send him forward 10 so that he's facing over here. So let's do that. So he's back there, so now we're going to turn him right 90 degrees and move him forward 10. So we run that. So we can see I forgot to raise his pen, so he's drawing an extra line that we do not want, and also you can see he ends up facing downwards, which is going to be an issue. But we'll leave that for how it is right now, just because I think it'll kind of look funny here. So remember, we need to draw 5 of these, right? We need to draw 5 squares. So we have theoretically a system where we would draw 1 square and then move him out of the way. Again, this movement is wrong right now, but I'll fix it in a second. So really what we want to do, instead of doing a square of size 20 and then moving to a new starting point and drawing it 4 more times, what we really want to do is just do it 5 times altogether. So I will move the turtle to a new starting point here, but I'm also going to put all of this in a for loop. So for I in range, and again we want to do it 5 times, and then you can I don't know if you're aware of this, but if you highlight multiple lines of code or even 1 line of code in the textbook and press tab, it will auto indent to the next indentation using 4 spaces. And again, you can also use shift tab to move backwards. So tab will move inwards, shift tab will move backwards. So make use of that. You can do multiple lines at once, like we're going to do right here. There we go, and that puts all of that inside that for loop. So let's see what happens if we run that now. Okay, so we have like this windmill looking thing now that we could use. Actually, if we wanted to make a turtle function that draws a windmill, we could add a body onto the bottom of that. So again, not what we want, and we already know what the problem is for that, and that is that we just simply need to turn our turtle back to the correct facing at the end. So what this should do is now draw 5 squares, again of all the same size, because we haven't actually set up a system so that it knows how to draw it at the increasing sizes that we want. So again, this gets us something interesting looking, but still not what we're actually looking for. So we need to now kind of address that. So we still want to do this. We want to draw 4 more squares, each 20 units larger than before. So how can we do this? And the answer is something that we learned about in this chapter. So give it a second and think about it. Pause the video, look back into the chapter, think about what we can do to get it so where we're drawing this square 20 bigger every single time. Alright, so the answer is using the accumulator pattern, which means that we're going to need 2 things. We're going to need an accumulator variable. Now, I'm not going to define my accumulator variable inside of here, right, inside of the for loop, because if I define it inside of the for loop and assign it inside of here, it's going to reset to this value every time the for loop runs. So make sure when you're using an accumulator variable that you aren't doing that, that you're defining it outside of the for loop. So I'm going to use an accumulator variable. I'm just going to call it sq_size for square size. I'm going to start it at our initial value of 20. So what I'm going to do now is use the accumulator pattern every time I go through this through this for loop here. So I'm going to every time I go through the for loop, call draw square, and then go through the reset here. That I could put this into a function, honestly, if I wanted to separate it out even further. Just call it like a reset turtle or something like that, which wouldn't be a totally accurate name, but would maybe be accurate for our purposes of it in this particular program. I'm not going to do that though. And then at the end of doing that reset, what we need to do is then accumulate onto our accumulator pattern. So we can do square size equals square size plus 20. Because we know that we want it to be 20 bigger each time. So each time it's going to go through and make a square that is 20 bigger, 20 units larger on each side. So that is essentially how the accumulator pattern works. You set up a variable outside of your loop, and then you accumulate that variable each time through the loop. And we've done kind of something like this before by using the variable I, our iterator variable, inside of our functions, where the first time through we would use 0, the second time through we would use 1, the third time through we would use 2. So we theoretically could figure out a way to kind of do that using I as our size variable here, but it's better to use it as an accumulator variable and use an accumulator pattern to achieve kind of the same thing. So that will draw a square of size 20 the first time through, and then increase that square size by 20 each time through the loop. So if we run this now, I know for a fact this isn't actually going to give us what we want because of a intentional flaw that I left in that I did not fix. And so hopefully you saw it as I was typing out the code. Hopefully you were looking at the code and you saw that I did set up the accumulator pattern, but I didn't actually use my accumulator variable anywhere in here. Now, obviously I should have stuck it right here. So now the first time through it will do that same 20 that we had there before. So we will replace this with this in our comments just to make it correct and clear. So it draws a square size, and it moves to a new starting point, and then increases the size by 20. So this time our program will almost be done, almost be finished, almost be correct. So at the end of this, we get these 5 squares in it, and it looks, fine and cool, right? But it doesn't match exactly what the specifications asked of us, and that's an easy fix. All we have to do is, before we move our turtle to his new starting point, we pick his pin up. Again, you can use just up. It's the same function. The method calls to the same function, so you can do that. And then when he's done, just go ahead and put his pin down. So pin down. Alright, now if we run it now, we will get something that is an almost exact replica of the original specifications. So we got 4, and then 5, and then he'll move out of the way. There you go. And we could have set his speed to faster if we want. Tailor speed, let's just set it to 0, so he'll just finish automatically. So run, bam, there we go. So it functions per specifications here, creates the same thing. So all we did was import turtle, define that draw square function, and then in our main body of our function, go through this. Now we could generalize this even more. We could generalize this square embiggening function even more. So let me save this, and actually what I'm going to do is I'm going to copy this code out of here, and instead I'm going to draw increasing squares, and it was 5 increasing squares. Awesome. So what I'm going to do is actually define another method. So in here I'm going to define draw, what are we going to call it? Draw larger squares. And again, we'll pass in a turtle. We will pass in a new function. We'll pass in start size, and we will pass in what we want to call it. We'll pass in inc for incrementer in this case. So it's going to take 3 parameters here. It'll accept 3 arguments: a turtle, a starting size for your first square, and then how much you want each square to increase by during each subsequent drawing. So actually, I'll go ahead and pass in another function, and we'll have it be what do you want to do it? We'll just say I for iterations. Okay, so I'll actually do X for iterations. There we go. This will draw X squares starting with size, start size, and increasing by inc. There we go. Okay, so let's just go ahead and start by pasting all this in here, right? So we want to then, this is what we wanted to do, right? We wanted to draw X squares, which is how many squares we wanted to draw, starting with start size and increasing by inc for incrementer. So we're going to have to replace all of our specific turtle names here with T, which is what we're using for our turtle variable, our turtle argument. So we'll just generalize those. We will make sure that we have so it will draw square T of square size. Again, we want to make sure that we're doing that correctly, so let's define square size out here. So square size equals start size. And now each time we go through, we will draw square size, reset it, and then this time, instead of increasing square size by 20, we're going to make it more general, increase it by our incrementer variable. So this function now does the same thing that we had it do down here. We get rid of this variable square size down here. This does all the same thing that we did before, and again, our program's perfectly fine before. This just is a way to separate as much of the repeated functionality that we might want to use out of the main function to make it so that if we want to change the number of times that we're drawing squares, or if we want to change the starting size of the squares, the incrementer of the squares, we can now do that all within the function call rather than having to go through our main function and try to figure out where all the references to those things are. So in this case, we will call our new function now instead. So we will call draw larger squares. We're going to pass in our turtle here, which is still Taylor. What else does this call for? It calls for a starting size, which we decided for the specification should be 20. We need an incrementer, which is again going to be 20. And we need how many times we want to draw it. In this case, we want to draw 5. So let's see if that works. So there we go. Does exactly the same thing, except now if I want to change up my program, I can now change that simply from the function call rather than having to go through and try to figure out where in my main body all that stuff comes from. So if I want to increase it to start at 30 and increase by 50 each time, I can just do that and cause a different functionality. Same thing for if I want to have it only do twice. Or if I want to have it do, let's say 10 times versus 5 times. Oh, there we go. I was like, why is it only doing... So I was having an issue here where it was only doing it 5 times. It's because up here I forgot to change our range here to use X instead of what we had hard-coded in here before. So we'll use X because that is the number of times. So now it should work. All right, so that makes 10. So you can see that technically this doesn't work exactly the same as what we had before, because when we're resetting it, we're still resetting it to only be moving back 10 and down 10 here. So if we don't want that, we can change that inside here. So if we think about it, what did we do before to get to these 10s? Well, what we did was we moved it back half of the incremented size and down half of the incremented size. So if we just want to do that here, what we can do is do it square size, do it incremented, the incrementer divided by -2. And then same here, incrementer divided by 2. So I use the incrementer rather than the square size, because technically they were the same number before. So if I do the square size instead, as long as the square size and the incrementer are the same values, it functions the same. But if they're different values, like they are in our function call here, is going to cause kind of weird sub effects. So we want to make sure that when we do it, that we have it use, that's all right, we have it use the incrementer as our backward and down reset numbers. So there we go. So we have a generalized function that does what this required of us. So we wrote a program that did exactly this, and then we just looked at that program and asked ourselves, what can we generalize from that, what we can compartmentalize from that to make an even more general program, so that if we want to change exactly what our program does, how many squares it draws, what the size of the squares are, what the increment is, all of that stuff, we made a general program now that draws bigger sets of squares that we could use to, if we had to change the specifications of what we wanted up here, we could do that nice and easily.